Hello friends, let's learn magnetic field due to straight current carrying conductor. For this, we require a straight current carrying conductor. Let us have it. This is a straight current carrying conductor, infinite in length. Let us take a small part of this conductor and current I is moving from X to violet. Then according to right hand thumb rule, or you can say right hand grip rule also, magnetic field can be obtained by your right hand grip rule. Here we are holding the current carrying wire by our right hand, then the thumb indicates the direction of current, then the grip will indicate the direction of magnetic field. So this grip is indicating the direction of magnetic field. So this is magnetic field is anti-clockwise here. Magnetic field is anti-clockwise. This is the center of the loop. Radius is R. Let us take a tangent here. Then magnetic field at this point is B. The small elementary length is dl. Elementary length is dl and B magnetic field, both are along the same direction. Both are along the same direction. So the angle between B and dl is 0 degree. Now according to Ampere's circuital law, what you have? You have closed integration B dot dl is equals to mu naught I total. So as B and dl are along the same direction, so the angle between B and dl is 0 degree. So you have B dl cos 0 degree here. It is mu naught I. Now let us take B outside. Take B outside. So you have closed integration of dl is equals to mu naught I. Here dl is the elementary length here. When we integrate it, close integrated, then we get the total circumference, which is 2 pi r. So here we have B into 2 pi r is equals to mu naught I. So B is equals to mu naught I upon 2 pi r. This is the equation for magnetic field due to a current carrying wire. Now direction of magnetic field can be obtained by two rules. Direction of magnetic field is obtained by either of two rules, and the rules are: number A, known as right hand thumb rule, which can also be known as right hand grip rule. So if you use right hand thumb rule, then here hold the current carrying wire by your right hand so that the thumb indicates the direction of current, then the grip indicates the direction of magnetic field. Same for right hand grip rule also, because grip will indicate the direction of magnetic field. So if the current is moving upside, then magnetic field is, here you are saying it is anti-clockwise, and if current is moving downside, then magnetic field will be clockwise. It can also obtained by another rule known as Maxwell screw rule. Maxwell screw rule. You know what is Maxwell screw rule? Now let us see how magnetic field will behave when current is moving upside. So suppose I am taking here a plane of paper. This is a wire here, and current is moving upside. Then according to your right hand grip rule, this is the magnetic field, which is anti-clockwise. Anti-clockwise. Now again I am taking a plane of paper. Let us have a wire. Current is moving downside. So hold it by your right hand. So the grip will indicate the direction of magnetic field, and this time the magnetic field is clockwise. It is clockwise. So this is anti-clockwise. Anti-clockwise magnetic field. Anti-clockwise magnetic field is indicated by north. Here, this is north. This is indicated by anti-clockwise, and clockwise magnetic field is indicated by south. If the magnetic field is normal to the plane of paper and it is inward normal to the plane of paper, then we indicate it by cross symbol. Cross symbol means inward perpendicular direction of magnetic field to the plane of paper. If you are indicating by dot, then dot means outward normal magnetic field. So if you indicate by dot, this is outward perpendicular normal magnetic field to the plane of paper. Thus you understand what is magnetic field due to a straight current carrying wire, and how we find the direction of magnetic field, and how magnetic field represents clockwise and anti-clockwise, and how we indicate it by north and south or dot and cross. Let us see a numerical based on this. A very nice numerical. Let us have it. Here it is a numerical for you. I am designing a numerical for you. I am taking two parallel wires, 1 and 2. Let this wire is said to be 1, this wire is said to be 2. Now this front wire, the current is moving upside. Let the current is I1, which is 20 ampere. And in wire 2, the current is moving downside, I2 is equals to 30 ampere. Let the distance between these two conductors are 20 centimeter. So this is 10 centimeter apart. This is 10 centimeter. This is 10 centimeter. Let us take a point here which is again 10 centimeter outside the conductor 1, and here another point which is again a 10 centimeter outside the conductor 2. Let this point is said to be, here a point is said to be, this is said to be point P. This point is P, this point is Q, and let us take a point here known as R. You have to determine magnetic field at point P, at Q, at R. The question is, what is magnetic field at point P, at Q, at R? So, according to your right hand grip rule, if I hold this current carrying wire by my right hand, then my thumb will indicate direction of current and grip indicate direction of magnetic field, and here it is clear that magnetic field will move anti-clockwise. So if it moves anti-clockwise, this means that at point P, the magnetic field is coming outward from the board. So here we get dot. This is said to be B1. And here it will inward, so we get a cross. This is B1 due to 1. Same if this magnetic field will advance in the radius, then at this point again we get a cross here due to B1. Now we are talking about magnetic field due to second wire. So due to second wire, the magnetic field, hold it by your right hand. So the thumb indicate direction of current, then the grip indicate direction of magnetic field, and here the grip is clockwise here. So if it's clockwise here, this means that magnetic field is outward at this point. So write a dot here, write B2. Here write a cross here, write B2. Here also write a cross here and write B2. Now here I have marked the name of magnetic field and also the directions. Now let us find magnetic field at point P, which is said to be BP. So B at P, magnetic field B at point P is B1 B1 which is coming outside and minus B2 which is going inside. Since these two magnetic fields are opposite in direction, so here I am taking minus sign. Now what is the formula just we get? We get the formula mu naught upon 2 pi I1 upon R1 minus mu naught upon 2 pi I2 upon R2. Let us take the common terms outside. You have mu naught upon 2 pi under bracket I1 upon R1 minus I2 upon R2. Now put the value. Value of mu naught is 4 pi 10 to the power minus 7 divided by 2 pi. What is I1? I1 is 20 ampere. So write here 20. What is R1? R1, let us see, this is 10 centimeter. So 10 centimeter means 0.1 meter. So write here 0.1 meter. Give a minus sign. Magnetic field current I2 is 30 ampere. Write here 30. And what will be the distance R2 at this point? See, this is 10, 10, 10, 10 plus 10, 20, 20 plus 10, 30. So the distance is 0.3 meter because 30 centimeter is 0.3 meter. Now let us solve it. So you have 2 pi will cancel out, 2 is here. So 2 10 to the power minus 7 under bracket, here it is 200. 3 will cancel out, here it is 100. So 200 minus 100 is 100. So you have 2 into 10 to the power minus 7 into 100, which is 2 into 10 to the power minus 5. Minus 5, this is conductor 1, minus 5 Tesla. And what about the direction? Since the sign come to be positive, so the direction will be of the B1. B1 have direction inward. So direction is inward. So direction is perpendicular to the plane of paper. Now let us find the magnetic field B2. So the second part is add, you have to find Q. So what is Q? BQ, let us see again here. So here this is cross also and this is cross. So these two have the same direction of magnetic field. Both are going inward to the plane of paper. So if they are going inward to the plane of paper, same direction, they add up. So we have a plus sign here. We have a plus sign here. We have a plus sign here. Now put the value again. What values are now in this case? In this case, here mu naught upon 2 pi, this is 4 pi 10 to the power minus 7. What is I1? I1 is same, what is 20. What is R1? R1 is, this is R1, which is 10 centimeter. This means that 0.1 meter. So write here 0.1 plus, this is 30 ampere. Sorry, it is 30 ampere. I have written M, please correct it. So here you have 30 upon, the distance is 10 centimeter, which you mean that 0.1 in meter. So this is divided by 2 pi. So again we cut this 2 pi, we have 2 here, 2 10 to the power minus 7 under bracket 200, here plus 300, which we mean by 500. 2 into 500 into 10 to the power minus 7, this means that 1000 10 to the power minus 7, which is 10 to the power minus 4 Tesla. And what about the direction? Both are cross. This means that they are inward to the plane of paper. So again we have the same direction, inward to the plane of paper. Now let us see the case number 3rd, C part. Magnetic field at point R. So when you talk about magnetic field at point R, then here this is 30 ampere, this is 20 ampere, and distance of first conductor to R is 10, 10, 10, 30 centimeter. So this is B2. So here magnetic field due to B1 is less and B2 is more. So here we will write B2 minus B1. B2 minus B1 is here. So here you write B2 minus B1. Now put the value and solve it again. So this is mu naught upon 2 pi I2 upon R1, mu naught upon 2 pi I1 upon R1. Take the constant term again, which is mu naught upon 2 pi under bracket I2 upon, here it is R2 minus I1 upon R1. Now this is 4 pi 10 to the power minus 7 upon 2 pi under bracket. What is I2? This is conductor 2, I2 is 30 ampere, right here 30. And R2 at point capital R. So this distance is R2, which is 10 centimeter. So it is 0.1 minus 20, and distance R due to first conductor is 10, 10, 20 plus 10, 30. So this is 0.3 in meter. So you have, again you have 2 here, 2 10 to the power minus 7 under bracket 300 minus 200 upon 3. So take the 100 outside. So you have 2 into 10 to the power minus 5, 3 minus 2 upon 3, 3 into 3, 9 minus 2, 7. So you have 2 into 7 upon 3, 10 to the power minus 5, which is 14 upon 3, 10 to the power minus 5. Divide 14 by 3. So you have 3, 4, 12, 2 on hand. So 20, 3, 6, 6, 10 to the power minus 5 Tesla, which you can write because 6, 6 are recurring. So you can write 4.7, 10 to the power minus 5 Tesla. Now what about the direction? So the answer come to be positive. So the direction is of positive sign magnetic field, which is B2. B2 is dot. So right here dot. This means that magnetic field is normally outwards to the plane of paper. Thus you have learned magnetic field due to straight current carrying wire, know how to find the direction and how to solve a critical numerical based on this. Do like, share and subscribe my channel. Thank you.